Hey guys, welcome to lesson 44 and 45. You definitely need your calculator for today, okay? And let's remember our trigonometric functions. We have sine equals what? Opposite over hypotenuse. So katoa. Cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent, okay? Remember, opposite is the one that goes across, adjacent is the one that touches it. So, look what it says in 44.1. It says that you need to find the missing parts of this triangle. So that means you need to find the H, find the B, and find the Y, okay? The B is super easy because you see that this is 24 and this is 90. So we're just going to go 90 plus 24 is 114. 180 minus 114 is going to be something that I should do in my head, but let's just do it with the calculator. 66 degrees. Okay, so B is going to be 66 degrees without you having to do anything fancy on your calculator. Okay, so let me just make sure that I typed that in correctly. Okay, so we're good with the angles inside. Then you can look at the outside of the right triangle and you can say, well, Ms. Jessica, can't we just use Pythagorean theorem? Well, you could use Pythagorean theorem if you had two sides, but you do not. You only have one side, so now you're going to have to use sine, cosine, and tangent. So what you're going to do is, like, let's say that you want to do y. So we could use either the 66 or the 24, honestly. We could use either one of those, but I'm going to use the 24, and I'm going to say, okay, let's see, that's opposite and adjacent is what that is, right? I'm using opposite and adjacent because I'm going to try to find a y using the 24 and the 9.5. Because I don't have the hypotenuse either, so that's not going to help to have two unknowns, okay? So I'm going to use the opposite over adjacent, which is your tangent. So I'm going to say tan 24. Tan 24 equals, opposite is y, and 9.5 is your adjacent, okay? Well, then you're going to solve for y. So I'm going to multiply the 9.5 by tan 24, and that's going to give me y, right? Okay? Watch it again if you're not processing it, but believe me, it has total sentido, and you will understand it if you process it, okay? So let's do it. 9.5 times the tan, not inverse tan, just tan, of 24. So it should look like this inside your calculator. Okay, 9.5 times tan 24. Your answer should be 4.23. In the book, it has 4.28. It's okay that it's one decimal point off because of how they did the finding y for them. Okay, 4.23. Now we know y, so what could we do now? We could do Pythagorean theorem, but I'm going to get more practice with using our sine, cosine, tangent, and I'm going to use one of those to find h, even though you could use your Pythagorean theorem, okay? So I'm going to use 24 again, and I'm going to say, okay, I know that this is adjacent and this is hypotenuse, so I'm going to do, trying to find the hypotenuse, I'm going to use the adjacent. Well, that's cosine, okay? So I'm going to do cosine, let's get this out of our way. Cosine equals adjacent over hypotenuse, so it's going to be cosine of 24 equals 9.5, 9.5 over hypotenuse, okay? Now this one, the 9.5 is on top, so you really have to crisscross and multiply. Okay, so that's going to be h cosine 24 equals 9.5, right? So then you have to divide that cosine 24 off of it, right, to get your h. So now it's going to be 9.5 divided by cosine 24. I'm going to put the cosine 24 in parentheses. I don't know if it makes a big difference, but it just makes me feel better. So it's going to look like this. 9.5 divided by cosine 24. Okay? So your answer should be 10.399, so 10.4 is going to be your answer there. And there you go for that triangle. Okay? If you're like, no, Miss Jessica, I'm not convinced, go back and look at it, or do this next one with me. We have 3 examples to see how confident we can get you. Okay, so let's look at this one right here. First thing I'm going to do is find B, super easy. 90 plus 35 is 125, so 180 minus 125 will give you 55. And that's your B, okay? Then I'm going to do the same thing we did before, but now we have the hypotenuse. So I'm going to use 35. I'm going to say, okay, I'm looking for opposite over hypotenuse to find your x. Opposite over hypotenuse is sine, so I'm going to do sine 35 equals opposite is x, and the h is 14, okay? I'll multiply the 14 over here, so it's gone, and x should be 14 times sine 35, like this in your calculator. So your answer is 8.03. 8.03, they have 7.98. Again, we don't care about the rounding issue, okay? Next one, I'm going to do adjacent over hypotenuse, same thing. Adjacent over hypotenuse is cosine, so we're going to go cosine 35. Happy days, it's a nice, easy one, because it's adjacent over hypotenuse, so it's going to be 14 times cosine 35, so that should give us 11.47. And there you go. That is your answer. Okay? Process it. If you need to watch it again, watch it again. I'm not going to stop the video. I'm just going to draw my example 3 up here. A squared, B squared. Okay, now this one's going to be cute because you don't have 2 angles, so you can't use the 180 minus whatever. But look what you can do. You can find x really, really easily using Pythagorean theorem. This is your C, this is your A, this is your B, so here we go. C squared plus x squared, 6 squared plus x squared equals 7 squared. So it's going to be 36 plus x squared equals 49. We minus 36, so it's going to be 13. X squared equals 13. So x equals the square root of 13. That one is the easy one. Now we have to find A and B. Okay, I'm going to use, let's see, to find A, I want to use the 6 and I want to use the 7. I don't want to use that ugly square root 13 because that's not going to be fun to use. So it's going to mean that it's going to go, this is adjacent to the A and this is hypotenuse to the A. So I'm going to use cosine. Cosine A equals 6 over 7, okay? Cosine A equals 6 over 7. Okay, 6 over 7 is 0.85, etc., okay? 6 divided by 7. Then you're going to take the inverse sign. Remember the cosine. Shift cosine. Shift cosine of this answer. 31. That's your degrees, okay? 31 degrees. Is that what the book says? Let's check it. Woohoo! We got it right. So this one's 31 degrees. And then you could do what? You could do 31 plus 90 is 121. Then subtract that from 180 and you get your B. But let's get some practice with another thing. Let's do B. That's going to be opposite over hypotenuse. So it's going to be sine B equals 6 over 7 as well. 6 divided by 7 is again 0.857. And then we do shift sine equals, and it's going to be 58.99, so 59 degrees. We can check that really easily because we can go 59 plus 31 plus 90. Woohoo! 180 degrees is what the answer is. So that means that your angles are perfectly fine inside. There you go. Go ahead and try your practice. I'll come back and give you the answers and we'll move into lesson 40. Okay, here we go. Let's check the answers to A and B. A is going to be the angle is 69 degrees, then the hypotenuse is 6.86, and the y is 2.46. Over here, P is 4 square root 13, y is 33.69, and x is 56.31. How did we do it? Well, here for 69, I did 21 plus 90, and then subtract that from 180 to get 69. Then in order to get y, I did tan. Remember, tan is opposite over adjacent, so I did the tan of 21. The opposite is y, and the adjacent is 6.4. So then I end up doing 6.4 times tan 21 to get y. This one is a little more complicated, but it's cosine 21, which is adjacent over hypotenuse, so it's 6.4 over h. We know after crisscrossing and multiplying and everything like that, where you just remember 6.4 divided by cosine 21 is going to give you 6.86. Or you could have done the Pythagorean theorem once you found one of the sides. Over here, I did the Pythagorean theorem first. 8 squared plus 12 squared, and take the square root of that, which was 208, but I reduced that down to take out 1 4. And it was 2 square root 52, take out another 4, square root 4, which is going to be 4 square root 13. Then over here I did tan x, opposite over adjacent, so 12 over 8, and I took the shift tan, the inverse tan. Then this one is tan y, 8 over 12, and take the shift tan after that. Okay, let's move on to lesson 45. Okay, I think you're going to enjoy this, but this is actually pretty short of a lesson. It's called the difference of two squares theorem, which, guys, it's super easy. If you know your rules for algebra, you're going to be able to figure it out without anybody even telling you about it, okay? But there's some like funky things in it, and so that part, I want to tell you the details. Look, remember that if you're going to solve for x in a problem like this, that your goal is to have x by itself, right? Okay, but what you need to do first, then, you need to get this little doodly bob guy off of there. Okay, well, what's the opposite of squaring something? Take the square root. So what I'm going to do is take the square root here, take the square root here. Okay, then you're going to have x plus 17 equals, this is where it gets really cute, okay? Plus or minus the square root of 2. That's the ugly part, okay? That's the part that's annoying, okay? Because now it's going to give us two different answers, but we know it should give us two different answers because we have a 2 right here for the x. So what are we going to do? We're going to move over the 17, so we have x equals negative 17 plus or minus the square root of 2. And that's literally your answer because it's this. Negative 17 plus the square root of 2 and negative 17 minus the square root of 2. Okay? Do you need to check that? Not something like that. It's ugly. You could check it if you're on a test, if you're in NASA. Love you. Thanks for letting me always talk about NASA. If you're in a huge exam or anything like that, like, you know, getting into college and you're like, I need to make sure this is right, you could test it. How do you make sure that you're getting it right? Just put that into your calculator. Negative 17 plus the square root of 2. It's going to give you a crazy decimal answer. You're going to plug that into the x. You're going to make sure it comes out to equal 2, and if it does, that means you're right. We know we're right because the book tells us we're right, and that's all we need to know for this class, but then you know how to check it. Okay, over here it's the same thing. It's just going to look a little bit more funky-doo. We got square root, so we're getting x plus 2/5 equals square root of 3 plus or minus that. You're going to move that 2/5 over here, so your answer is x equals negative 2/5 plus or minus the square root of 3. Literally your entire answer. Okay? Love it. So easy. Go ahead and do your practice. We'll come back and check it in like... Okay, here we go. A is x equals plus or minus the square root of 14. So you just take the square root. Over here, you take the square root, you get x plus 9 equals the plus or minus square root 11. So you bring the negative 9 over, and it's negative 9 plus or minus square root 11 for your answer. Over here, you do the same thing, but it's with a negative 1/7. So you bring the negative 1/7 over here, plus or minus square root 8. Bada bing, bada boom, you are done. Oops, we can, in fact, simplify that 8. It's going to be 2 square root 2. Even better of an answer. Okay? There you go. Enjoy your lesson for today and have a great day.